All right, so I'm going to solve the same circuit I just solved in the previous video, but this time I'm going to use a different method. I'm going to use nodal analysis. And so if you recall, nodal analysis calls us to basically set up an equation for all the currents leaving a node where we don't know the voltage. So we know the voltage at Vy right off the bat again, right? It's 12 volts, so we can just write that right out the gate. Let me get my values from the previous slide. Need these. Okay, let's just slap these in here. Oops, I hope that didn't get rid of what I, yeah, okay, good. All right, good. So we know Vy, we don't know Vx, but what we do know is we know that I2, that current, or sorry, we know that this node has a KVL or a KCL that we can write. So let's do that. We know this node, it has a couple of currents. It's got the current from the current source, and it's got I1 and it's got I2. Well, because we only need Vx, we can very easily solve this circuit using nodal analysis. So let's do that. The current entering, which is I2 basically, is going to be, or let's just write the KCL to start. Let's just call this big I1. We know that the currents entering the node, the sum of the currents entering the node has to be equal to the sum of the currents leaving the node. So in this case, I've got little I2 as the current entering the node, and then leaving the node, I've got my big I1 plus my little I1. Forgive me for the notation in this circuit. I shouldn't have called them both I1, but it's too late now. So let's just leave it. And I can write out an expression for I2, which is going to be Vy, right? The voltage across R2 is going to be Vy minus Vx divided by R2, which is 200 ohms. And then I could just, write this as 12 volts. That's going to be equal to I1, which is Vx over 100 ohms, plus my current through my current source, which is 25 milliamps. Right? And so right here, I only have one unknown, so I can just go ahead and do the algebra now that I set up my equation here using nodal analysis. And I can solve for Vx, and once I get Vx, finding I1, finding I2, and finding I3 are all trivial. So let's go ahead and do that. I'm going to multiply both sides by 200, so that's going to get rid of my fraction. So basically, let me just move everything over. And then right here, I'll multiply by 200. And here I'll multiply by 200. So the 200 goes away on this side. I get 12 volts minus Vx is going to be equal to 2Vx plus, so 0.2 times 25 milliamps, or 0.2K times 25 milliamps is basically going to give me a 1.25 volts. Okay. That right? That seems right. That seems wrong. I think it's going to be 5 volts. Let me just throw it in my calculator so I don't screw it up, but I'm pretty sure that that's going to be 5 volts. 0.025 times 200. Yep, 5 volts. Okay, great. So now I have 12 volts minus 5 volts is going to give me 3Vx, right? Yep, that's right. And I can say that Vx is going to be equal to 7 over 3, which is, again, 2.333 volts, which is exactly what we got last time. All right, so we got our 2.33 volts. We have our Vy equals 12 volts, of course. And now we just need to go ahead and solve for the currents, which again is trivial. I3, of course, is going to be 12 volts divided by R3, which is 400. And I'm going to get 30 milliamps there again, like I did last time. I2 is going to be 12 volts minus 2.33 volts divided by 200 ohms. I don't remember exactly what the value is, so let me do it real quick. 12 minus 2.333 divided by 200. Oh, that's right, 48.3 milliamps. So that's check. And then I3, of course, is just going to be Vx over R1, which is 2.333 volts divided by 100, which gives me 23.3 milliamps. All right, and so there are my answers. I've got I3, I've got I2, I1, and of course I already found my voltages. Okay, so that's how you would solve the circuit using nodal analysis. Don't even need source transformation. If you want more practice, of course you can go ahead and try and solve this problem using superposition or mesh analysis, and you can go ahead and verify that these are the correct answers. I built this circuit in Spice, obviously confirmed that these are correct, and you could do the same if you want. But in the next video, I'm going to solve a different example problem using some different circuit methods that we've learned and kind of just talk through the process like I've been doing. All right, so I'm going to go ahead and end this video.